The broadcast is now starting. All attendees are in listen-only mode.
Okay, good afternoon, everybody, and this is Dr. Mansour, and today is the last surveying class in the first quarter. Welcome, all of you. I hope that all of you are healthy and everybody is doing fine. Um, uh, take care of yourself, take care of your family, take care of your neighbor, take care of of everybody, because we need everybody to stay healthy, first of all, and after that, exams and studying and all these things comes after the health. Okay. I was here this morning. I was teaching this AM class this morning. This is a free series of workshops this summer. Started with the civil AM this morning. We talked about structure mechanics. We have some problems and we have some discussions about different topics. I hope that everybody enjoyed it this morning, and I will scan and send the notes, and hopefully my staff can work from home to load the lecture. We'll see how can we load it and make it available for free also during summer if we can. Tomorrow I will be here for transportation from 9 to 12. Also, this is free, all of them with one ID. So one ID will be sufficient for all these sessions, the civil breadth and the transportation and the construction. We are going to start, or I will start teaching the courses in July. I hope that the situation will be better in July and everybody is stay healthy also. So in July 11, I will start the AM using my 3 books here, and the NCAAS, they might come up with a new book. I'm following up with that. And we'll continue from where we stopped. As I mentioned, we stopped last time when we stopped in chapter 7, in fact, materials, but I will go back 1 chapter, geometrics, and so on. And the transportation and construction and all these things. As far as seismic and surveying, I will start teaching. I'm teaching seismic. In fact, tomorrow is the last session of the first quarter. So by tomorrow, I believe I have about 55 hours or maybe even 60, because I added more sessions to catch. And I will start teaching again the course at the beginning of April, but the course will be the 55 hours. I calculated to be about 50 hours, but I believe it's more than that. Somebody is working on putting everything right now as on demand, but I will have live 28 hours live, which is equivalent to a course by some other vendors, just to be workshop, to go over problems. I will use the 626 book. The other 2 books, the 300 and the seismic practice exams and solutions, are included here. The 626 seismic problems, they came from my textbook, which is based on the new code, the ASE 7-16 and so on. So, and this is for those who attended the first session. They will attend the second session for free, obviously, because the exams are postponed. So, and those who are going to join me, they will have access to the first time, they will have access to the 55. So the moment you enroll, the books are in stock and we can ship it. Okay. All my books are right now, I'm trying to do all my best to have it here in stock and ship, okay, the same day or next day. Surveying also, I will be starting teaching the course for 18, which is April 18, which is Saturday, which is the in fact after the PE exam. The PE exam, as you know, it used to be April 17, but it was canceled, as all of you know. So I am still working on the second edition. These books are the second edition, if I'm not mistaken. Yeah, the second edition here. And they have a brief description. The second edition, I took the first edition, which I'm still using until now, the 4 books, and enhance it and improve it and get rid of any typo or mistake if there's any typo or mistake. And these books has been rated very high. All my books have been rated reasonably high. Let me put it that way, or I will leave it up to you. Rated by the engineers who used them before on Amazon. If you go to Amazon, and you will be able to see. If you attended a class with us, you will be entitled to attend this entire course. This course is from scratch. I will be teaching the entire course, which is about 55 hours. And I will be glad to send you the books again. Those who are attended the class with us before, I will be glad to send the books. Even it costs me a lot of money, but I will do my best to help you during this crisis. And okay, and those who are going to enroll the first time, obviously they will receive it. So let us do our best, and I will do all my best. I'm working extremely hard in these circumstances. And I provide a brief description of all my books. You can read it. This brochure available on our website. I believe the webmaster is working on it right now as we speak, because I gave it to him yesterday. So the description or the brief description of each book um, is given, and I hope that these books will help you to pass this exam, as I've been doing this for the last 30 years or so. So having said that, sorry for this introduction, but I have to say that the surveying today is the surveying. One of you, I believe there is some kind of question or something like that. I receive, okay, Larry. Hello, yes, hi, Larry. Can you go over a problem 132, 310? Okay, sure. Do you know if we need, okay, to reapply for the exam with the board? I really don't know. This is another question from Kelly. Let me make sure that I pronounce correctly, because the print. Kelly, okay, Kelly, so not Kelly, okay. I really don't know. You need to reapply again. I really don't know. Apply for the exam with the board. If we are unable, okay, to take the test due to this COVID, okay, cancellation. I believe you should be able to take the exam, as far as I know, without for free, because if they cancel the exam and if you paid everything, they should reschedule the exam. Simply reschedule the exam. Faisal is asking any idea how the exam will be rescheduled. I have no idea. I'm just reading whatever the website, either the California board website or the NCAA's website. Those are the only two sources. I don't have any other sources. So just, but be ready for the exam as fast as you can. And this will be my advice. Don't slow down. Those who were scheduled for the exam, assume that you are going to take the exam as originally scheduled. Cancellation of the exam gives you more time. My quarter is over. Do you think they will extend? My quarter is over. Do you think they will extend? Are you talking about us as professional engineering service and education, or the board? No, you will attend. I mean the board. Oh, I really don't know. I'm sure that they are going to break all the rules. Okay, they have, as far as I hope you might have insight. No, in fact, no, I don't have any insight with the board. I don't really. I have some of my students way back. They used to work for the board, but I don't really have any inside information from the board at all now. Just I'm watching or reading what is on the website, and which this is what I recommend you to be ready for the exam. And I hope that they will communicate with you, because they have all the information about everything. But let's do our best. Let's assume that the exam, for those who are scheduled to take the exam the first quarter, assume that you are going to take in the first quarter, and be ready at any moment, the moment that the situation will allow for opening the resites again. Obviously, we should be ready for it. This will be my advice. Assume that you are okay. So if you're scheduled to take the exam the first quarter, let us keep working hard, keep studying and working hard, and go over all the questions or problems, anything, and you can do in order to make yourself ready, and in fact maybe make yourself not 100%, 150% ready, so at least you can take the exam and get rid of it. So if first quarter today is I think almost done, tomorrow and after tomorrow the first quarter, so the second quarter, what will happen to the second quarter? Does the prometric site will be available or not? I hope very soon, but be ready. This is only okay. And let me know how can I help you. Let us go to the questions. At least we can. I believe some of you asked me some questions, and you are very welcome to ask me. I think I can remember, and forgive me. I know. Let me. I used to have it here. Uh, 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 let me try to organize myself a little bit here. I have tons of work around me, but I can take the questions. Okay, I know Larry, he asked a couple questions. Let me get the numbers from the 497 book. You are asking to go over problems number 132, 310 of the 497 book. That's correct, 132, yes. And I believe, Kelly, I believe you have a question, if I'm not mistaken, either you or somebody who sent me a question, and I said I will discuss it. I will be glad to discuss it. And I printed to tell you that, and I have it. Let me unmute you, Kelly, and you can ask the question. At least I can refresh my memory about it, if I'm not mistaken. Kelly, you aren't here. Can you speak out, please? Kelly?
I don't think I had a question.
I beg your pardon?
I'm sorry. I have a question.
You don't have a question? The sound is
No.
breaking. Okay, that's probably I mix your name with somebody maybe. Okay, somebody sent an email to me and I replied. I said that come Saturday I will be glad to go over the question. At least everybody will get the benefit. If okay, let's go to the two questions our friend asked. Problem 132. Let's go to see 132 of the 497. First 132. Where is 132? Okay, here it is. At least if you don't have the book with you, this is a problem 132. You can read it, and again, I will be glad to copy it and scan it and send it to you if you don't have the book. Said existing ground is level across the street cross section. The existing and the proposed elevations are given in the following table. What grading would be placed on the right curb stake for the top of the curb at station 2 plus 00? This is station here. So as you know, curb stake, okay, curb, as you know, is a concrete. So we have curb by itself, and we have different types of curbs, and curb and gutter is another construction element. So when you look to the center line of a street, for example, center line, okay, and we have the pavement, assuming that this is AC pavement, asphalt or HMA, or asphalt concrete, AC, sorry, AC, asphalt concrete. So the pavement, it does have a slope, or the cross slope, which is 2%. At the end here, we add something, either a curb by itself. A curb is a concrete element. It has a certain slope and certain height, and there are different types of curbs. So this is a concrete element here, okay, 6-inch curb. And the pavement, so the curb is like this. I'm just trying to exaggerate the curb. Here it is. So, and the sidewalk will be behind it. Sidewalk, okay. So this is a sidewalk, and this is a curb. This is a curb. And as I said, this is concrete element. Um, Normally it is cast in place. So it is a cast in place element at the job site. They put the forms and they cast it in place. It has a certain slope, and the dimension here about 6 inches. And I said that there are many types of curbs. I know that he will ask you. And this is the flow line, FL. As you know, the flow line is the lowest point that we need the water to run, okay, across the flow line. And the profile of the road, because the road is extended that way, as you know, it's like that. So the water will run this way, whatever the grade is, based on the profile of the road, which is a vertical curve. And the water will be taken to any DI drainage inlet, and the water will be stored somewhere in a basin. This is the surface runoff, SRO. It's called surface runoff. Okay, this is the rain or storm, from any storm, and all of you went through the 8-hour exam, and we use this equation. Q is equal the CIA, the rational formula to calculate the amount of the water that will be accumulated, and based on the area, and based on the rain intensity, and based on the C, which is a runoff coefficient, depends on the type of the surface, and so on. So the curb and gutter, this is a curb. The curb and gutter is also a concrete element that it does have also, but cast in place. Let me try to draw it as accurate as I can. Okay. Or we can slope it all the way up to here. Let's make it this type, which is making more sense. Other type is very, very old. So also it is a sloped. Here it is. And also we put the sidewalk behind it. Sidewalk, normally concrete. And also this is about 6 inches. And this is a certain slope. And this is also the flow line. And this is also concrete cast in place. And they probably saw it. They have some machine nowadays to do that. And instead of putting the forms and okay. So this is also this is curb and gutter. This is the flow line where and this is called the lip of the gutter. The lip of the gutter. And this term, by the way, in my textbook, chapter 12, which is a construction, the construction, there are some pictures or some sections are taken from Caltrans, the construction book, the construction surveying book, or the surveying book construction section. Let me put it that way. There is here it is. It is the lip of the gutter. LIP. It is the lip of the gutter. So this is on page, by the way, 296. If you have my textbook, page 296. At least you know this is the top view. This is a top view. Okay. Or elevation, as we call it, elevation. Top view. So you see here it is. This is the FL, the flow line, and this is the lip of the gutter. And this is so if you look to the cross section here, if you'd like to draw a cross section for this, okay, like that, you will find exactly this is what I'm talking about. It is like this, and here it is, and this has some kind of slope. Okay, so this is the lip of the gutter. This is the lip, LIP, and this is the flow line, FL, the flow line elevation. So basically, this is, if you look from the top, this is a side view. This is a side view, not top view. This is a side view from the side. So this is the lip of the gutter, and the pavement will come here, and the flow line and the sidewalk will be somewhere here. So what they do, in order to construct this in the field, there is a stake, reference stake. This stake is behind, okay, we put the stake somewhere here. This is the OG, below, put the stake somewhere here. So a stake, as I mentioned before, it is a piece of wood. This stake here is the piece of wood that will be driven into the ground. And this stake is the reference stake. It's called reference stake, stake. And this reference stake that will be used where you put the rod. I need you to understand the concept. This is why I'm going over this instead of just open the book and here is the solution of the problem and that's it. No, because as I said, that's without understanding the problem correctly, it will be okay. Understand the concept. It just is not. So we need to be aware of that. We need to be aware of the way that. So there is a stake somewhere here, and this stake we call it reference stake. Next to the reference stake, we are putting something is called witness stake. Witness stake, which is long one, 4 feet. This is as you can see here from the. Let me take the camera out here and this is the driven stake. The stake will be driven into the ground, except we leave 1 inch on the top, and we'll color it as you can see, or spray it with this. So when you put the rod, you put the rod on top of it, because I know the elevation of top of this stake here, and this is written here on the witness stake next to it. So this is a witness stake. This is about 4 feet, 4 to 6 feet long, and we drive it next to it like this stake here. I have one here, very long, okay, very long, here it is. And we put the information, the header information and the cluster information, and I will be glad to elaborate on that. So this stake is going to be, okay, 4 to 6 feet to be visible and seen by the people. Oh, so we know that there is a stake over there. I will come and put the surveying rod on top of it. So the rod where all the elevations and distances. So this is the surveying rod. This is the rod, and we can determine the location of the flow line, the location of the lip, the location of the end of the saddle. Any design parameter can be determined. So what is written on the witness stake, which is in reference to the reference stake, okay, which is shown here. Normally we keep it about 2 or 3 feet away from the construction, so nobody will damage it, and all the measurements will be taken from this reference stake, as we know from chapter 12, staking information. So this is something that, okay, so what is given in the problem, interesting information, and this introduction here, I hope that explains what is given there. So the proposed elevation and the existing elevation, okay, and the ground, okay, in the level cross section, okay, straight. The proposed elevation are given in the following table. The curb stake and so on. There is a cross section. I believe that it should be included with this problem, and probably this is what what probably missing, unless the text I should add it here as to explain what is the cross section. But if I remember correctly, this is why I draw the cross section. First, the cross section, the width of the road or the width of the lanes must be given. But let me answer you first. Let me just answer one of you raising the hand. Probably you have a question related to this. What is the face of the curb? This is the face of the curb. The where I draw it, here it is. Okay. This is the entire thing is called the face of the curb. Okay, but we normally take the flow line elevation as the controlling point. So the controlling point is going to be, okay, like this is a curb and gutter. This is called the face of the curb and gutter, but the flow line is the controlling one. The controlling one. Okay. So so if you look to the problem, as I said, that probably the cross section, I believe it should be given because there are some information. Let me draw it, the cross section, if I remember correctly. Okay, the slope, the cross slope, normally the cross slope is 2%. However, in certain situation, we could have different cross slope from that. So the curb here, the curb, whatever the curb size, this is the face of the curb. Okay, if you'd like to make it okay, side like that or vertical, I have no problem. But for the calculation, it does not make any difference. So this is a vertical curb, and this is a vertical curb. Okay, and the sidewalk will be coming after that. Okay, if you like to make it sloped like that, I have no problem. Okay, I believe you are missing something here, or we are missing something here, because I look to my drawing. I have another drawing that this distance must be given to you, or the cross section 20 feet width of the road. Okay, and this is the profile grid, as you know, the PG. Because I was reviewing this problem last week. In fact, I was in updating my books. I looked to this problem and I said, okay, I think we need to describe the cross section or give the cross section as part of the problem. And I just opened another book. I found that this is the case. Yes, this is the case. So so this 20 feet, and the cross slope normally 2%, but I believe in the problem is given as 1%. The proposed elevation is 128.1. This is the elevation here. Okay, the elevation here 128.1. No, the elevation is the elevation of the center line, sorry, which is a profile grade. Okay, so the elevation, the profile grade, the BG, so this elevation must be given as 128.1, either given to you directly or given to you in a form of a vertical curve. So this cross section has to go with it, 128. So 128, so I can get the elevation here. So the elevation of the flow line, which is the face of the curve, so the elevation of the flow line, okay, what grading would be placed, okay, at the right curb stake for the top of the curb at station 2. Okay, so right now I have 128.10. So it is here, and since I have this slope here is 1% at 20 feet, so it is minus 20 feet times 1%. As I told you, this cross slope must be given either 1% or 2%. For this specific problem, the cross section is, so this is the elevation is 127.9 feet. This is the elevation here at this point here. Okay, so so this is the elevation here. The existing elevation at this station is also 128.1. This is lower than this. Okay, so right now, do I have cut or fill? Since this my finished elevation, and this is the existing elevation. So the existing elevation of the OG is here. Okay, or existing elevation is here. Sorry, it's 128.10, and I know they are the same. This is why I said, wait a second. Okay, and the finished elevation is here for at the face of the curve. The finished elevation, which is at the flow line, this elevation is 127.9 feet. Okay, so I am below the original ground. That means that I have cut. Because as you know, when we have the OG, the original ground, this OG here, and which is normally we request this by sending a survey request, and somebody will go and survey the original ground, which we call it the terrain, or we call it DTM, Digital Terrain Model, DTM, which is basically the elevations of the existing ground. Our profile, okay, will determine if we are in cut or fill. So if this is my profile grade here, this is a profile grade which is BG. This is for the center line, and this is applicable to any situation. So other than the center, normally the BG normally at the center line, the profile grade. Okay, for any given street or road, we prefer the center line to be the profile grade, but sometimes we have a separate two profile grades. We have some roads, they have two separate ones, one higher than the other one. So each one, it has its own profile grade. So in this case, since we are OG above this one here, so we have cut, and here we have fill. And this is the rule, as all of you know, that if we are higher than the OG, we are in fill. If we are below, we are in cut. So going back to this problem here, you will find that we do have OG is 128.1, and we have the finished grade or the face of the curve or the flow line elevation is. So the difference between them, this is a cut. So if we take the difference between 128.1 minus 127.9 feet, so this will give you, okay, 0.2 tenths, sorry, of yeah, this is 2/10 of cut, and this is supposed to be, okay, the answer. And here we have here repeated answers here, 0.2 cut and 0.2 fill. So in this case, so probably this is what that probably throw you off, that the cross section or the description of the problem. We could describe this, by the way. We can describe this cross section, say that, and this is what I was looking, as I told you. So describe the problem, describe the problem as far as the cross section, because it's missing. To be fair, problem, describe the problem, or give a cross section. Give a cross section. Because after I read it, I went to another book because I have a similar problem, and I found that the cross section must be given to you. Okay, so this is what I will add or modify as far either to describe the cross section. It's 20 foot, okay, 20 feet cross section, or 40 foot road width. And we normally assume the center line in the middle, so 20 at a cross slope of 1% or 2%, and the problem could, okay. So, and he specifically at station 2. So this is what we are comparing the existing with the proposed, or the proposed elevation with the existing. And normally the proposed elevation, this is normally at the center line, because which is a profile grade where all the elevations will be measured with respect to that. Okay, so this is something that probably throw you off a little bit. But if you look to the construction book, construction chapter 12, you will find, Larry, something similar to this. This is a stake. This is a stake. If you flip the page, you will find on page 297 of my book, 297 of my textbook, you will find a textbook explaining the stake cut, flow line, the lip of the curb, and so on. So it gives you insight about how to translate any given statement to some kind of drawing or illustration. So this is one thing. Okay. So this is 132. So I wrote a note here to myself. So let me put a tab here. At least I can. Okay. The second problem you are requesting is 310. Let us see 310. I hope 310 is not missing anything. 310. Okay, here it is. 310. 310. Okay. So 310 is again, this is a cross section at station 12 plus 00. And the cross section here, this is OG, original ground, OG. Normally OG here, it is shaded, so probably OG normally it is shown as a dotted line or a dropped line. It would be a good idea, but since it is shown as shaded, sometimes we use this. And is asking what is the area of the fill. So the proposed cross section is like this. It is 40 feet wide, and this is the center line. And we have some stake information. And let me zoom in, at least you can look to the cross section much better. And let me. Okay, so this is a road. It's 40 feet wide, and we have 2 to 1, 2 horizontal, 1 vertical, 2 horizontal, 1 vertical, and this is the OG. So for sure we do have a fill. And he is asking what is the area of the fill area. The area of the fill is needed in order to calculate the volume, because if we do have a road like this, this is in a fill. So in this case, we need to get the area here, if this is the OG like that, and I am building a facility like this. So I have a fill area here. This is station 12 plus 00. And probably at another station, okay, somewhere here. Okay, so this probably station 13 plus 00, 100-foot station here. So the cross section here and the cross section here, A1, for example, and A2 will help me, or will enable me to do the volume computation using the average in the area method. As all of you know, volume using the average in the area, average in the area, which is basically A1 plus A2 divided by 2 times L, and we divide by 27 to convert it to cubic yard F. But the basic equation, it is A1 plus A2 divided by 2 times L. This is the basic equation that we use it for the average in the area method to get the volume, the average in the area method, in the area. Okay. So the So the first step in volume computations is to find the areas. And this is what as a first step is to calculate the area of the fill. Immediately problem, the following problem, it is the area of the area of cut. In fact, this is a cut. It is the letter C indicating that. Here the letter F is indicating that. So because again this is the OG. Again, normally the OG is dotted line, or since we are showing as a shaded area, it is acceptable to do that. So this is, they are giving you the cut. How much cut with respect to the profile grade. This is a profile grade, by the way. This is BG, a profile grade, which you normally at the center line of the road. Like this one here, also the profile grade is somewhere here, BG. So to calculate the area, either in case of a fill section like this or cut area like this, in this case, we need to be remembering that the area computation, let me just bring you to speed here. So the area calculations, there are more than one way to do it, to calculate the area. Number one, which normally I recommend, look to how this area can be broken down simple shapes or divided into simple shapes. This will be my first choice. Like the one we are going to solve this problem here, I will break it into simple shapes. Triangles, trapezoids, circles. I mean, so the triangles, trapezoids, circles, squares, whatever shapes can you can generate. So simple shapes, this is almost, I would say that my preference, leave me with that. Okay, always I recommend that first. Some problems, he gave you the shape or the area that you are required to calculate the area, and he's giving you coordinates. So we use coordinates. He gave you a parcel like this. This is A, B, C, D, E. But he gave you the coordinates, the northern and the eastern at each corner. Or X and Y. The moment I see coordinates that given at each corner of this parcel here, and is asking what is the area, what is the area, that means that he is asking you to calculate the area using coordinates, as I discussed in chapter 8 of my book. All this, by the way, in chapter 8 of my textbook, chapter 8. And it's very powerful method, by the way. But we need to remember that using the coordinates will give you twice the area. Double the area. You have to divide by 2, because among the answers, I'm expecting that he will give you an answer that it match twice the area, and I can come up with some kind of problem right now, or I can go over some problems given in my book. But just, there is another method, also we discussed it in chapter 8. It's called DMD, double meridian distance. Double meridian distance method. DMD. It is very lengthy because you have to get the DMD first, and after that you multiply it by the latitude, and it's a very lengthy process. And this also, it gives you twice the area, but he might give you something already. He calculated the double meridian distances and he give you in a form of a table and ask you what is the area. But to generate everything from scratch, it will take more than 3 minutes. But coordinates, expect that you should expect something like this in the exam, where a shape can be given like this, and this coordinate here, for example, if this is A, it is 20 and 40. This is 60 and 90, assuming that, and this is 20 and 120, and let's assume that this is negative 50 and 85. Let's assume that this is given to you. Just I made the problem based on my, so given coordinates, northern and eastern, in order for each corner, and here I put one minus specifically. And what is the area of this parcel, or this area of this shape, or a parcel land? Okay, this is it could be as you recall using coordinates. The way we do it, we put these coordinates horizontally or vertically. Coordinates, by the way, it does have another name. It's called the crisscross. Crisscross. Another name. So if you look to this, you will find that I need to put the coordinates. I start with A, and you don't, and as long as you start with same order, northern, eastern, I have no problem. Okay, so it is 20, 40. The second one is 60, 90. So these are the northern coordinates, and this is the eastern coordinates. And 20, 120 minus 50, 85. If you have coordinates with negative sign, you have to enter it with negative sign. It's something, okay, it happened before, and it was very confusion to some engineers, okay, because as we are going to see the process of computing the area using coordinates, we have a plus side and minus side. So, but you enter the coordinates. One requirement for the coordinates method or the crisscross method is to repeat the first coordinate. So I start with 20, 40, and I list all the four corners. I have to end it with 20, 40. So this must be repeated. This is a requirement for the coordinates method. Repeated coordinates. of the first point, sorry, coordinates. You have to do that. If you didn't do it, you'll get. After that, we do the following. You multiply this times this, and this times this, and this times this, and this times this. And as you can see here, we have 4 sides. 1, 2, 3, 4. You have 4 multiplications. So, and we'll consider this is a plus. And I will do it in front of you right now. And you are going to take the opposite direction, which is a minus. Okay? This is 20 here. Okay, just to make sure. This is the minus side, and it does not make any difference which one is a plus, which one is minus. Is not a big deal, because we take the absolute value of the area at the end, because the area there, it cannot be negative. So I will say minus this time this, this time this, this time this, and this time this. And again, because we have 4 sides, we have 4 multiplications. So I will say that twice the area, 2 area, don't forget the 2, is equal to. I will take the pluses first. It's 20 times 90. A plus. 60 times 120. A plus. 20 times 85. A plus. Minus 50 times 40. And I will close the bracket. So I finished the 4 multiplications that are in red. All these are pluses, but because I have one coordinate is negative, I put it as S. I will subtract this minus the green. So those are the red. I should use the red. Those are the red multiplications. Minus the green. Don't forget this minus here. Minus 20 times 85. Minus 50 times 120. Sorry, a plus, sorry, because I put the minus here. A plus. I put the minus, I factor the minus outside, so minus all these. And 20 times 90. And finally, a plus 60 times 40. So this is the way we do it. I will collect all the terms here in the red, and I collect all the terms in the green. And take the difference between them. And this will give me twice the area. The area is equal 1/2. So if you allow me to do this very quick, you can help me by doing this with me, please. 20 enter 90 times, 60 enter 120 times plus, and 20 enter 85 times plus, and 50 minus enter 40 times plus. I got here all the red areas 87, or the red 8700. And correct me if I'm wrong. And when you receive my notes, it will be scanned and sent to you. If it's not today or tomorrow, it will be most likely Monday, because I'm really, really busy with a lot of things. So maybe somebody can help me. Okay, and I will take 2085. This green, 20 enter, 85 times. Please do it with me, please. And 50 minus enter, 120 times plus, and 20 enter, 90 times plus, and 60 enter 40 times plus. Okay, so this one here give me, the green give me minus 100. Let me do it one more time just to make sure that 20 enter 85 times, and 50 enter 120 times plus, and 20 enter 90 times a plus, and 60 enter 40 times a plus. Yeah, I get. So in this case, the final answer will be for this problem that I said that twice the area, 2 area is equal to the red numbers 8700 and minus, but since this is minus 100, the green, so it is equal 8700 plus 100 will give me 8800. Okay, this is twice the area. So the area by itself, the area is equal 88 divided by 2, or simply 4400 square foot. Or so this my final answer. So the area for that, and you can do it, area is equal 4400 square foot. This is the way we do it. Please do it again when you receive this. Do it at home and make sure that you understand, because this is, it happened in the past and we need to understand. The reason I'm doing this problem, because going back to the original question that was asked by our friend Larry, asking, what is this here? The area here. And let me just draw it very quick, at least when you receive my notes will be making more sense. I'll make a copy of this page also to send it to you for those of you who do not have the book. So this is the OG. And here is the center line. And I have a road. And I have a fill. And I have a fill as such slopes. Oops, I didn't put my center line in the centers. Let me move it a little bit. At least it will make more sense to you. Sorry, I didn't. Okay, should be in the middle here. It seems that. Okay. So this is the center line, and we call this as a profile grade BG. And he said that this is 40 feet. That means that's 20 feet here and 20 feet here. Normally, the center line in the middle, okay? The center line in the middle, okay? And this, we call it HB, hinge point. And this is also, we call it HB, hinge point. And we call this point here catch point CB. And we call this also CB, catch point. All these abbreviations that we use, I hope that you are familiar with it. If not, I have a very good list in chapter 12 of my textbook, or at the beginning of the book, it does have the list, a complete list of abbreviations at the beginning. He gave you the sud slopes. He said that it is 2 to 1. 2 horizontal, 1 vertical, 2 horizontal, 1 vertical. And he gave you some key. He said that this is a stake here and there's a fill, indicating this fill 8.2. And this is a fill along the center line here. The fill along the center line, or at the center line, I have a fill F of 6.7, and I have a fill at this catch point here, fill of 5.6. And this is what is indicated in the problem statement itself, as you can see here. Okay. So knowing that, here we go. Knowing that, now we can start to work. So I need to find the area. As I told you, there are the three methods: simple shapes, number two, coordinates, or the crisscross, as we call it, crisscross. And there is another method I will mention, by the way, because you might be asked about that, and the DMD. Or let me add the fourth one right now, which is area from a reference line. You will see it. So from a reference line, I will talk about this or show you in my book how did, because I think also this could be a target for a question. Could be. But let's finish this. So if you look to the four options I have here, the four options for this given problem, you will find that coordinates, yes, you can do that. You can establish your coordinate here and go around by some key points. But again, you have to establish your coordinate system, and you can select any point, by the way. You can select any point to be your reference or your reference for your coordinate system. So can I use the coordinate system or the coordinates method solve this problem? The answer is yes, but it will take time. DMD, forget it. You need about half an hour. And you have to establish bearing and distance and all these things. It's too much. A reference from a line is not applicable in this case. So normally I look, as I told you, this is why I always rank this to be my first choice. Unless you can, by the way, this problem, you can solve it also using coordinates, using also the simple shapes. You can break it down to a simple shapes like that. Break it down to simple shapes and see A1 plus A2 plus A3 plus A4, but you have to be careful with coordinates. But I prefer to use this directly. The moment I see coordinates given in the problem statement, that means that he is directing me to use the coordinates. And as I said, don't forget to repeat the first two coordinates of the first point. You start from here, you go around. Normally we prefer clockwise. And the area, if you ended with a negative, for example, if the numbers, and we have some numbers, this number here, the red 87 and the green negative 100, maybe this is 87 plus, maybe this is 9,000 negative. I take the difference between them. Okay. So be careful about that. Okay. So I take the absolute value because area cannot be negative, even if the negative area is more than the positive areas. So in this case, I take the difference between them based on this sign here. Okay, so I needed to be aware of that. Okay, I am getting close, my friend. Okay, I know some of you, okay, raise a hand, but normally sometimes I wait until I finish my concept and after that. So here, in this case, we can work the problem. And the easiest way, as I told you, simple shapes. So in this case, I can break it down to triangles and trapezoids. You can sometimes we complete the area to be like this and subtract. For example, I can complete it like that, like 2 trapezoids.